Kirk math. All right, ladies and gentlemen, here we are with 6-1. We are looking at rational exponents and properties of exponents. In your student companion, we're on page 116 and 118. Today, we're just going to do part 1. We're going to do examples 1 and 2 and then practice those, okay? So we're splitting this into 2 videos. So as you can see over on our left, so I have 2 sides today, but on our left, we're going to start looking into what are radicals using rational exponents. We have this new feature here, which is a number with a power that's a fraction. And we need to figure out what does that mean. So in order to understand that, we have to go back to the basics of exponents. So exponents, 3 to the second power is the same as 3 times 3, right? You're multiplying the number 3, the base, by itself 2 times. 3 to the third power is 3 times 3 times 3, multiplying the base by itself 3 times. 3 to the fourth power, right, etc. However, if I have 3 to the fractional power of 1/2, so 3 to the power of 1/2, what does that mean? Because I can't multiply 3 by itself 1/2 times, right? Like this right here does not match this. So because we don't know what that is, we're going to go ahead and rearrange this equation a bit so that it makes sense to us. So what we're going to do is we're going to go ahead and square 3 to the power of 1/2. Our power of a power property tells me I'm going to multiply these exponents. So I have 1/2 times 2, which is 1. So 3 to the power of 1/2 to the power of 2 is the same as 3. Okay, what does that mean? How's that going to help us? So what we need to know here is a power whose square is 3 is the square root of 3. So in order to define raising the power to 1/2, we have to relate it to the radical or square root of 3. So this is where you're going to take your notes here. So basically all of this is just how we get to this rule or meaning here. It's down here in little letters if you want to work it there. Or if you come over to the other side, I'm going to take this off. I've kind of written it out on over here. So we know that the square root of 9 is 3 times 3 and that the cube root of 27, cube being the number that's little in front of this little radical symbol, is 3 times 3 times 3. So knowing what we know here about squaring a fraction, our rule is any number raised to a fractional power is equal to that number and that root. So if this number was a to the, oops, sorry. Oh, here, let me just. All right, try this again. If my thing is a to the power of 1/5, then I'm going to have the 5th root, I'm going to put a 5 there, of a. So sorry. Okay. Okay, so then likewise, if I have a term to the power of a fraction that does not have a 1 as a numerator, then that is going to go on the inside of my square root side. So for example, let's just do a number here. So if I had a to the power of 2/3, right, that's going to equal so my denominator is n, so 3 is going to be my root, and then my letter is going to get to the power of my numerator. Okay, so let's do a number 1. 2 to the 2/3 is going to be, again, this still is a cube root here, but then my 2 is going to get squared inside. So then if I were to equal that, I would still have 3 cube root. 2 times 2 is 4, so it would be the cube root of 4, and that would be my answer. Sorry. All right, go ahead and try it on your own. Can you turn this into a radical using from the rational exponent? All right, one more example, and then we're going to do some practice problems. This one is where we're using the product of powers property with our rational exponents. So you can see here we have 3 to the x over 2 times 3 to the x over 3 powers equals 3 to the 9ths. All right, so in order to do this, and I know it's kind of hard to see over here. Let me actually see if I can zoom. Okay, so you might see this a little bit better, so I would take some notes here. So here's my problem. The first thing I'm going to do is do my products of powers property. So I'm going to, because I'm doing a same base power being multiplied, I'm going to add my exponents. So I'm adding x over 2 plus x over 3. Now we're going to write our exponents with a common denominator because these are still fractions and I have to have a common denominator to add fractions. So we multiplied x over 2 by 3 to get 3x over 6 and x over 3 by 2 to get 2x over 6. Then we're going to add them together and we're going to get 5x over 6. Now, when you have the same bases in a problem, you can set the exponents equal to each other because the bases are the same. So it doesn't really matter what the bases are. They basically eliminate or cancel out. And I'm left with 5x equals 6, or 5x divided by 6 equals 9. Okay, and now I can solve my problem normally. Multiply both sides by 6 over 5. Or multiply both sides by 6 and divide by 5. And you're going to get left with x equals 54/5. And that's our answer. Okay. All right, so now you try the one in the textbook yourself and see if you can figure it out. And then when you're done, head on over to page 118 and we're going to do some practice problems together. All right, we are on page 118 of your student companion, and we're going to do problems 7 through 14 only. I'm going to do a couple with you, but then I'm going to let you do some on your own. So the first one we're going to check out here is we're actually going backwards. We're going to take this radical and we're going to turn it into an exponent with rational numbers. So if you remember, I'm going to do my work over here. If you remember, when I had my problem here that looked like this, the denominator becomes the root right here. And a, because our numerator is a 1, a is going to be by itself. So we can also think of that going backwards, okay? So if I have a root, whatever root it is, okay, I'm going to turn it into into the number that's inside of the radical is going to become your variable or your coefficient, your base. That's what it is. It's going to become your base. And then the number that's in your radical here, the power, the root, is going to become the denominator of your problem. Okay. So if I have the square root of 7, you should know that this has a little invisible 2 because that's a square root sign. So that's really a 2. So this is going to turn into 7 and 1/2. So that is the first one. Number 7 is 7 and 1/2. And we can double check that here. If you don't believe me, right there. Okay, you try 15 on your own, or number 8, square root of 15. Let's do number 9 together. Okay, so over on this side, we're going to do number 9, which is the cube root of 6 to the 4th power. So again, m and n, and I've got n here and m. So if I look at my original model here and apply it to this problem, that tells me that my answer is going to be, because I'm going to go backwards, 6 as my base. My numerator is going to be 4. My denominator will be 3. 6 to the 4/3. And again, we'll check our answer. There you go. So now you go ahead and do 10 on your own. Actually, you can probably go ahead and do 10 and 11 and 12. Pause the video, fill those guys out, and when you're ready, meet back here and we're going to do 13. We have 2 more to do. So I'm going to do 13. I'm going to let you do 14. So this is that problem that we have to do a little bit more work for. Okay, and we're going to use those properties of exponents to help us solve. So I'm going to start by writing out my problem a little bit bigger because I know it's hard to see. 3. Ooh. Oh my gosh. I'm going to pause and write this out. All right, so the first thing I'm going to do is I'm multiplying powers that have the same base, so I'm going to add my exponents. So I'm going to do x plus x to the second, and this all still equals 2 to the 5th. Okay, that means that I am now going to have common denominators. So my next step is to get common denominators, so let's go ahead and multiply 3. We're going to multiply this fraction by 2 and this fraction by 3. I'll be back. All right, there we go. So now I'm going to add my 2 things together. So I will end up with 5x over 6. Still all equal to 2 to the 5th power. All right, so now this is the part where it says because my bases are the same and I'm equaling each other, I can cancel out my bases and keep my exponents equal to each other. Okay, so here's my new problem, and now I just have to solve for x. So if we do it the way that they did it in the example, I can actually just, because this is really 5/6 x, I can just multiply by the reciprocal. You can also multiply by 6 and divide by 5 separately if you need to. So in the end, I multiplied both sides by 6 over 5. These cancel out, I'm left with just x, or you could do 6 times 5 divided by 5 times 6, which is 1. And then same thing over here, I canceled my 5s, I'm left with just 6, or you could do 5 times 6 divided by 5, which is still 6. So my answer to this problem should be 6. There you go. So go ahead and try 14, and that's all we have today. We'll practice these problems tomorrow, and then there'll be a part 2 where we'll do the rest of the examples. Good luck.